everyone, I'm really excited to interview Robert Otani. He is principal of Core Studio at Thornton Tomasetti. He served as an adjunct assistant professor at Columbia University and visiting assistant professor at Pratt Institute. In this episode, you will get to know about Robert's journey and work of Core Studio. So without much ado, we'll jump into the interview process. Hi Robert, can you tell us about yourself?
About myself, sure. Well, I guess it's a reference to my position currently. So, yeah, I started. I've been a structural engineer, and I still do structural engineering since I joined Thornton Tomasetti in 1995. That's after getting a master's degree from Penn State University in structural engineering, and I did leave the company, went to a couple of different companies, and then came back in 2008. And then we started what is now called Core Studio back in 2011. And so I think the pertinent point of how I got to start to be, sort of to start this team, but also be involved in the goal of the team is that I started before everyone had a computer. So in 1995, Thornton Tomasetti was about 100 to 150 people, I think, in only New York City. So now we have 50 offices, but now at the time it was only New York. And maybe we had 4 or 5 computers in the entire office of 150 plus people. So, that sort of tells you where I started from, right? Anyway.
Interesting. And what inspired you to become a structural engineer?
I didn't know. I had to say, I did graduate with an undergraduate degree in 1990. Worked for 2.5 years at a civil sanitary engineering firm, and learned a lot about construction, somewhat about design, a lot about field work, because I was mostly an field inspector. But I didn't really, that wasn't my passion. And I just remember being in undergraduate school, I also had, a liking to structural engineering and buildings. So that's when I decided to, quit my job and go back to college to get a master's degree.
How does a day in your life look like?
The day in my life currently is is all over the place. So I have, and it's because sort of where I'm situated in the firm as chief technology officer. So what that means is, yes, I run Core Studio on a day-to-day basis, but also have regular daily meetings with senior leadership in the firm about certain initiatives. And also I still work on projects. So there's always project work that comes up during the day. So that is mainly what I work on during the day. So it's, connecting to senior leadership, project work, and Core Studio management.
Mm-hmm.
Yeah.
And if you can name a book that had the biggest impact on your life or your career, what would that be and why?
Book. I'm not a huge book reader, so I will say the book that I'm most familiar with is engineering books. And so I would say structural engineering book that my professor at Penn State University was the author of, structural analysis book, Dr. Harry West, who was a phenomenal teacher. He's the one that really sort of made structural engineering click for me, because I was not the greatest structural engineering student in college. I mean, I ended up with a 3.2 or something, but but structures was actually not my best, sort of coursework. And partially because for some reason in undergraduate, they start you with doing virtual work. And I always thought that was a little abstract for, designing beams and columns. And it didn't click with me back then. But with Dr. West, it completely did. So anyway,
Yeah.
That's why that book rings a bell with me.
That's interesting. And like diving into my next question, any role model or mentor who made a significant contribution in your life?
In my life, of course, it's always going to be my parents, I think. My dad was an engineer, chemical engineer, traveled the world back in the 60s and 70s. My mom was an artist. So between the two, I sort of got in the middle, I think, between that. So it starts with my parents. On the professional side, there's been many, and I recently I was participated in an event that the Structural Engineers Association of New York organized, which was about mentorship. And or mentoring young engineers. And I always said that I was telling a lot of the young engineers there that really the goal of a young engineer is to learn as much as possible from everybody. It's not one person. It's because there's many people with expertise in different things. And the point being is if you can learn learn what the experts know in each particular technical category, well, sooner or later you become a really well-rounded engineer, right? So it's not like you just know steel design or concrete design or whatever. If you know it all, then that will prepare you with the tools to be a really solid engineer, handle any project.
And can you share challenges faced in your career and how did you resolve it?
Yeah, that's a good one. So I would say the biggest challenge was the transition from being a technical engineer to becoming a project manager, because the skills are very different. So as a technical engineer, the skills that you need are obviously very good, a good technical background, knowledge of codes, being productive in designing a building or whatever part of the building you're designing. But then when you switch over to project management, it becomes a lot about managing people, collaborating with people, and managing project finances. Those are things that you don't learn as an engineer. And so that was a big challenge for me, which I had to improve upon. I knew I had to do that.
Yeah. And we'll now move into our next section, which will talk about your project work and professional work. So can you give us an overview about the work of Core Studio?
Yeah. So Core Studio started actually in 2011. And in 2011, at the time I was, one of the few people in the office who had already completed a BIM project. BIM was relatively new at that time. So I used to be sort of the person who would, present at architects off the clients' offices about, how great Thornton Tomasetti was at BIM, right? Because that was still relatively new at that time. I knew Revit and all of that back then. But then I was again, I remember, I think I mentioned I was started teaching in 2008. And I remember seeing students use Grasshopper in 2010, I believe, is when Grasshopper first came out. And, you know, that was something that I could get my head around in terms of, you know, I was thinking that's something I could do. So around 2000, in about that time, myself and Jonathan Schumacher, he and I took a course on Grasshopper. You know, took as a weekend-long course, and we started experimenting with parametric design. There was some software out there by still around. John Merchant has a software called Geometry Gym, which we were one of the first engineers to start utilizing GeoGym. I call it GeoGym, which would connect Grasshopper models, Grasshopper definitions to SAP 2000 and Revit. So, so that's how it started, and we decided to create a group, a team within the office. We called it Advanced Computational Modeling because that's what we were doing. And then, you know, then it just grew from there. You know, started growing the team, started growing, you know, the type of work that we did. It went beyond modeling, it became development, and it became art research and development.
I see. Can you walk us through a particular project of Core Studio? Like how do you approach and challenges and their final output?
Well, really, there's two subsets, if I really want to explain Core Studio, because we are both a, you know, an advanced computational modeling team, as well as software development, applications development team. So on the computational modeling part, you know, I would say we've done many, but I would say our probably most advanced workflows has been with some 3D modeling, 3D printing projects that we've worked on, which was, there was a project called One City in Nashville, Tennessee, which is still the world's largest spanning 3D printed structure with Branch Technology. They're a 3D printing startup out of Chattanooga, Tennessee. And so that project computationally was very complex. The material was the material that we had no data on, so we had to do physical tests to compute physical properties of the material. It was not an isotropic material, so it was anisotropic, or more accurately, orthotropic material. So, and we had very short time to design that project. So we had to do a combination of, you know, form finding, topology optimization, and a lot of coordination to get the right geometry for that particular project to match with the material and the design intent. So that was probably one of the most complex computational modeling projects that I've worked on. On the development side, there's probably too many to name, because we've been doing software development for since 2012. But I would say the most robust product is the software called Construe. So Construe is a public software now. There still isn't a product that is equivalent to Construe, which, you know, something that we started developing in 2012, actually. So it is a bi-directional interoperability platform that has a very robust data schema. So that's probably the most, you know, sort of complex software that we've worked on.
Sounds quite interesting. Thanks a lot for sharing. What are some upcoming projects for Core Studio?
Well, Well, you took the class, right, or at least the Swarm class, and so Swarm is we're in alpha right now, but we're getting ready to go to to the next stage with beta. There's which a lot of, in my mind, beta, it really means just getting the product stable, listening to your customers and making certain adjustments to make it a more usable software. So I think Swarm is going to be a significant one, and I think we are also looking to build out a suite of core apps, which are some are already available, like Mirar, Thread. What else is available? To some extent, we have something called Skipper that's available, but it's more about sort of rounding out the project design process and having the right tools for each stage of the design process. So early design all the way to sort of construction documents levels design.
Mm-hmm.
Yeah.
And according to you, what are the emerging trends in computational design that will shape our working in next 10 years?
In simple terms, it's going to be automation. So automation of processes. And in a way, we've targeted, I would say, various aspects of an engineer's workflow: beam design, column design, shear wall design. And so, but there isn't like one application that you can do everything in, and partially because it's not easy to do. So just doing one of those things is months and months of work to get it right, to get it so that engineers trust it. So and we're still doing that. So I think we'll continue to do that. But once you get to that level, then you tie it into machine learning and artificial intelligence. Then you get true automation, right? But we're not completely there yet. I mean, I don't know if you've seen, but we released Asterisk, which is a machine learning based building design tool, and I still haven't seen a tool like that. It wasn't perfect, but if it still can design a building in under a minute, So we actually have a Swarm app for that now. So I think that's going to be the future of structural engineering. It's going to be varying degrees of automation in our process.
Mm-hmm. And what do you think are the roadblocks currently faced by building industry to adopt new technology?
Yeah. So there's a couple of things. One is just technology itself. Even a year or two prior, there's some things like in Swarm that we just couldn't do that we could do now. So technology changes and improves constantly. So you have to be on top of those things. You have to be at the cutting edge if you're going to be building really, smart tools. So technology is one. The other is human adoption. So, I've kind of mentioned this. I think it was Nate Miller from the Proving Ground who called it professional bias. I think he called it, and that's a you can interpret that a different way. I interpreted that as being, if you tell an engineer, or it doesn't matter, structural engineer, or architect, or whoever it may be, who has been practicing for 30 years, that the way they're doing things is the slow way, or not the right way, then and those are people, many of those people are leading firms, right? Then you get a resistance to integrating certain technologies into practice because it just wasn't, they think it's wrong, let's just say. And so that's where I think it's not going to be a gradual increase in the use of technology. It's going to exponential as time goes by, because it's a generational issue in terms of a technology adoption. I mentioned in 1995, we had 3 computers or 4 computers in the entire office. So what that means is someone who has 30 to 40 years experience spent 20 years plus of their career without a computer. And then you're telling them to use artificial intelligence tomorrow. That's a rough one to swallow. So that's always going to be an issue, I think. So, the next wave, the generational wave, which is people in their 30s now, I think that's when you'll see significant, sort of leveraging of technology.
Yeah.
Not that we aren't using it every day now, but I'm just saying in terms of accelerating, the use of technology.
I see. And like, what do you suggest to people who are like in the older generation who want to use technology, but they are not very skillful at using this?
Well, I think so that's a good question. First of all, they don't necessarily need to. They're not producing. Usually, those people with 30 years experience are not producing, building designs, but they are consuming building designs. In other words, they need to review documents, communicate with their engineers and their designers, and be able to still manage the project. I would say projects are a lot faster than they used to be because of technology. So in my mind, you can't review projects the same way you did 30 years ago, which was print out a set of drawings and look at your desk. One, desks don't even fit drawings that size anymore. 2, the design changes day to day. And so the day you print out a drawing is probably an old set of drawings. And the metadata that is in our BIM models can't be produced on flat sheets of paper. So I think what we would try to do, or we're trying to do right now, even with some of our core apps, is have a way to communicate digitally the same information, or it's actually more information to project managers and senior folks, so they can be a significant part of the process.
Now we will move to our final section, which is about advice to students and young professionals. So, Mr. Robert, what is the best advice you have ever received till date?
I think the best advice was some advice that one of our founders, Charlie Thornton, gave to me when I was a young engineer back in the 90s. And he said, always have a vision. Have a 5-year vision. And then leading up to that 5-year vision, you do everything in your power on a day-to-day basis to reach that vision. And obviously the vision changes every year, probably. But if you don't have the vision, then you're not actually acting as a focused person, right, for your future goals. So I think that was really important, because I think that's what everybody needs to do. They need to have a vision, and they need to know how to get there, which means taking a very good look at yourself, your skills, your strengths and weaknesses, and build upon your strengths and build upon and learn, so that you don't have those same weaknesses anymore. So I think that's really important.
What will be your advice to students and young professionals who are interested in this area?
Well, obviously, to learn something new every day, that's the goal. Like, you can't be complacent. And the minute you think that you are good at something is probably the minute that someone's going to be better than you. And the other thing is, I think technology will drive the entirety of our industry. And so, you know, when I talk about machine learning and automation, well, what that means is there will be a subset of the traditional engineering or design community that will be replaced to some extent, because our tools will be able to do basically what they do on a day-to-day basis. So I think the advice would be to stay ahead. I think software development is actually going to be a day-to-day part of engineering. It's not just knowing math and science and physics. It's software development is going to be part of the process too. Not necessarily building full-on apps, but building tools, I think, will be really important.
And like, will that be a part of the education itself?
That is a hard one. Education has not changed. I shouldn't say that. It is starting to change, but it's probably not as fast as it should be. It should be part of the engineer. I think I don't know if at Illinois, but there are some schools that are starting to teach software development, right? Some courses here or there. I learned a little bit of software development too, way back. It was Fortran and Basic, but it wasn't. It was more about learning logic as opposed to actual software. So I think they're, not that I want to add to an engineer's burden, because engineers already have a very packed 4 years of undergraduate. But, I'm thinking engineering is probably a 5-year program at a minimum. That's just a bachelor's to add those additional skills that are going to be necessary. And of course, there's always a master's degree, and then you can focus a little bit more. But yeah, I think you need to add some time to learn those skills. But again, I think it's going to be easier for younger folks because they grew up with technology, right? Yeah. So.
And can you share some resources which would be useful to people who are interested to learn more about computational design and its application in the industry, like some conference books or courses?
There's some books out there. I would say that's probably not the best, because again, technology changes so fast that once you write it in a book, it's probably old to start with. I think there's a lot of online courses, like ours, that have sort of the latest, greatest technologies. Obviously, to follow Rhino Grasshopper, like Rhino 3D's website, because they have listings of courses and online workshops constantly, and I think that's where that's probably the best starting point. And then there's courses, there's Udemy, or what it's called, Course Horse and things like that a lot of folks in my team also take those courses, just to freshen up on some programming language or some new language or something. I guess the point is it's a constant learning process, especially with parametric design, because if you don't use it every day, you forget it. And I know myself, every time because I don't use it very often, if I try Grasshopper, I have to relearn it again, seemingly. So as a young engineer, though, I think that shouldn't be an issue.
Mm-hmm. And how students can use these tools in their design?
Well, I mean, the one thing that the tools do is they make iterations easier. I mean, that's the whole point of parametric design. But there's also no shortage of learning the craft of engineering, which is more about gaining a sense of what is right or wrong even before doing any engineering at all. That takes some time. So, you don't want to start building a parametric model without knowing your goal, right? I think the idea of parametric modeling is really having a sense of sort of sensitivity and optimization of a design problem, but not necessarily blindly, creating thousands of designs to figure out what you probably should have known from the start. So I think, and I think that's where the industry is struggling a bit, because there's parametric design that does thousands of iterations, and then there's people with 30 or 40 years experience telling you to do this one, but again, that's that one iteration is limiting, and the thousands of iterations are time consuming, even if it's parametric. So there is somewhere in between, there's a balance, and there's the right sort of way to, option your buildings or designs.
Yeah. And is there any question which you never get asked but would like to answer?
Well, I would say, yeah. So, well, I shouldn't say this. This has been asked before, but it doesn't get asked probably often enough. And that is, how does an organization sort of start a core studio-like entity? Because it's a big leap, right? It's more than just hiring a person. It's more than, on the surface, it's expensive, right? Because you're not necessarily hiring people for a particular project or a paying project. And obviously hiring the right people is not easy either. But we've always in Core Studio have justified our existence by demonstrating very clearly that our return on investment is minimum 5. So if they spend $100,000 in Core Studio, which is a lot more than that now, they're going to get a return of $500,000 or more. And that's, you have to make it. The reason why I say 5, because, sometimes the return on investment is not about profit making. It's about having happier clients. It's about responding faster to, project design iterations. It's about making, again, doing some of those mundane tasks faster, so that you can actually do other more creative or more complex things in your process. So it's not going to show up on paper necessarily, but it will show up in a better product. And so, I think that's where the industry is. There's very few teams like ours. I think if firms did it the right way, they would see significant gains. And I think 5 to 10 years from now, if you're not doing software development in your engineering firm or architecture firm, you're probably going to be behind.
I see.
Yeah.
And how can our listeners follow you and your work?
Well, they can always, get me on LinkedIn, but, Core, does these AEC Tech Academy workshops pretty regularly. We also have our website, at thorntontomasetti.com. We have a whole section for Core. And I do a lot of conferences. I speak at a lot of conferences. We have our own conference that's going to be virtual this year in October under the AEC Tech umbrella. So I think the website is .us. Let me just check. Yeah. So aectech.us is our website for sort of public facing events. We have a YouTube page, you have an Instagram page. So you'll see the YouTube page, which we put the Swarm, Fred Morar workshops up on YouTube. We've been posting content up there since 2011 or 12, I think. So there's a lot there.
And personally, I have attended the Swarm workshop and it was really, really insightful and helpful. So thanks a lot for organizing those.
Yeah, no problem. We're part of the reason why we're doing that is to get it's an alpha product. So we're trying to get feedback to improve the product. So the more people we get to give it a shot, the better.
I really, really appreciate your time for this interview.
Yeah, no, I appreciate the ask, and glad to support the industry for the next generation of computational designers.